All right, here we go. Top 10 reasons the universe is not expanding. Number 10, Methusa. This star is 190 light years away from Earth, and it's one of the oldest objects in the known universe. There's different estimates for its age, some older than the observable universe, which does not make sense at all. There's other examples of stars like this too. This is not the only one. But 190 light years from us, I did some calculations. This means that astronomers searched 3.1 times 10 to the negative 22% of the observable universe. That's 21 zeros, and then it's 0.00. That's 21 zeros, and then 3.111% of the observable universe, and they found the oldest star in the observable universe. If we compare that to Earth, it's like searching an area with a radius of 3.6 inches. It's like if we looked in an area that was 3.6 inches, had a radius of 3.6 inches, and then we found a little pebble, and then we were like, this is the oldest rock on Earth. It's absurd. It's absurd. Number 9. Oh, I want to mention before we get to number 9. I know that was a dramatic number 9, and then I just paused. But there are also superstructures. There's these giant things that take forever to build. Like gravity takes a long time to drag objects in and, build a structure. Like it just takes a long time. And there are these objects like the big ring in the sky, the big arc in the sky. There's all these different structures is what I call them. I mean, it's just cosmological objects, and they take billions of years, trillions of years, some of them probably. And so it's just obvious if there's objects that are older than the estimated age of the universe that something's wrong with the estimated age of the universe. Number 9. How about that? Dogmatism, atheism, materialism, and scientific fraud. Now this one's a little controversial, but I think it's important to throw in there. Cosmology is the worst. Well, physics is bad, but cosmology is the worst in physics. Like just the comments that I get, the people that are interested in physics, like there's some amazing, really cool people out there that are interested in physics, and then there's a bunch of idiots, lunatics, crackpots. I mean, I'm a little crackpotty, I have a little bit of conspiracy theorist in me. I have a little bit of, alien woo-woo interests, but I'm pretty stable, I feel like. Pretty grounded, rational, reasonable. A lot of people think that cosmologists are reasonable. They are not. Most cosmologists are not reasonable people. In fact, most theoretical physicists are not reasonable people. I mean, this is anecdotal. Of course, this is anecdotal, but it's to me, it's like they are on a mission to prove Christianity wrong, or all religions. And I don't care. I don't have a dog in the fight. I'm agnostic towards it all, but I mean, I don't know. I'm more Gnostic than anything. Like I think that you should question all these things, like the existence of God. You should definitely do lots of thinking on all of that type of stuff. And I think you should be able to let your mind roam. But cosmology, they think that they have figured it out with the Big Bang. And, Darwinian evolution kind of plays a huge role in that. It's like they want to be able to tell the story of the Big Bang and evolution, and that's how we got here, and there is no reason to believe in the Bible. That's that's what it seems like to me. I don't know. It just seems to me that way. Let's listen to Oh, fuzzy.
We all know the universe is expanding, so if you run the clock backwards, if you run the film to the past, 14 billion years ago, it was in a hot, dense state. And we have something called the Big Bang model of cosmology, which is simply the statement that 14 billion years ago, the universe was in a hot, dense state. It expanded and cooled and went from being very smooth to relatively lumpy, which it is right now with all these stars and galaxies and so forth. That's the Big Bang model. It is true. There's no point in doubting the Big Bang model, okay? We don't let people up here on stage if they doubt that part of the Big Bang model.
It's just absurd. It's just absolutely absurd. If you doubt the Big Bang model, if you doubt the Big Bang, it's not even if you have your own lunatic theory. No, it's if you doubt in the Big Bang model, then they don't let you on stage. You know, it's just like, whatever, dude. Oh, I don't want to listen to you again. No. Number 8. Expansion is an... Let me start over. Number 8. Expansion is an assumption. Okay, see, these are the Friedman equations and the Friedman metric, or the FLRW metric. Expansion is an assumption, and we're going to get into this. And if you've seen my other videos, you already know that this is a pet peeve of mine. But it's all an assumption. Like, the entire theory is based on an assumption that the universe is expanding. Number 7. JWST data. So there's actually been a giant narrative shift. There are lots and lots of articles out there about, should we change cosmology? Just the other day, I saw a video that was released by the World Science Fair, I think it's what it's called. It was like cosmology, crisis in cosmology or something like that. And people are starting to see through it. Like, if you look at the archive and you just type in JWST, you want to pinpoint I would say JWST high redshift, stuff like that. If you do keyword searches for that, there's just tons of articles. Now, none of them are published, and they probably never will be published. Some of them are getting published though, but they're finding just ridiculously old galaxies way out there. And it's just hilarious because they will always find old galaxies no matter what, because the universe is a lot older than 13.7 billion years. Well, I don't know that. The universe could be 13.7 billion years old. It's just not expanding. Dark matter. Now, dark matter is kind of a side note. It's a little asterisk. It really doesn't. It's really not. It doesn't, affect cosmology per se, but it does show you the complications that come with cosmology, with astronomy, with all of this stuff. Everybody thinks that they know what they're doing, and it's extremely complicated. And all you have to do is read a daggum science article about it, and you'll understand how complicated it is. And so, when they're talking about stuff like dark matter, then you just can't help but to be like, well, it's hard. So you tried, you put up a good fight, guys. Number 5, dark energy. Dark energy is going through a new crisis. Apparently, there's some new research that come out that says that I don't exactly know what it is, so I'm not even going to comment. But this is one of them things that it's always going to be like that. It's because it's a non-existent phenomenon. This is a redshift anomaly. This is not an expansion anomaly. But just the idea that they had to, just the fact that they had to theorize dark energy means that there's something majorly wrong, right? Like, that is a majorly wrong thing. That doesn't help cosmology. It hurts the cosmological model. It's not evidence for the cosmological model. It's evidence against the cosmological model. Number 4, inflation. Just like dark energy, it's so stupid. It's so stupid. You can't even, it's not even scientific. The inflationary epoch of cosmology is not science. It's literally not science. It's just this goo of energy expanded outward at a rapid rate. Look at this. So this is the rate of expansion. You know, this is not even accurate. Like, I tried my best to get ChatGPT to make one, and we went through like 40 different versions, and I'm like, whatever, this is fine. I had to remove the billions of years off the bottom, because like it's what it was doing was calculating Hubble's law at the observable radius. And it's like, no, that's not what you do. That's not how you do it. Like, but it still shows that in the early universe, like, you know, less than 1 second, the universe was just super fast, like Speed Racer, expanding at the fastest possible rate ever. And then it hit the brakes, and then slowly started to expand, and then it's accelerating, and it will continue to accelerate. It's just absurd. It's absolutely absurd. Things don't move like that. Number 3, the cosmological principle. Alright, so Einstein spent a lot of time thinking about how to use math to formulate the universe. In this paper, Cosmological Considerations in the General Theory of Relativity, he talks about some of the complications that he ran into early on. One of those is that because gravity decreases r squared, according to the inverse square law. So it arises with complications, but if you have infinite space, that would mean that you have an infinitely low density, that's, you know, so it doesn't even exist. And so it's just hard to do with math. One of the things that I don't know if it was this paper, but one of the notions is that that developed during this early period is something called the cosmological principle, and it's often described today as the universe being homogeneous and isotropic. It basically just means that the universe should look approximately the same on the largest scales for all observers. Now, whether or not that's homogeneous and isotropic depends a little bit on your definitions of homogeneous and isotropic. Number 1, the universe is not homogeneous. That's fairly obvious, I think. Now, Einstein used a homogeneous universe in this paper, in most of all of these, in everything. Homogeneity is just the natural starting point, because you can say that the universe doesn't have infinite space, it has an infinite homogeneous mass density. And so it's just a way to move the calculations along, okay? However, if you rewind the universe using modern cosmology, it does not fit the cosmological principle. So why does the cosmological principle exist if it didn't apply to the universe in the early universe? Number 2, assumptions are not evidence. Again, I've already mentioned that expansion is an assumption, but oftentimes there are people that like to pretend the assumptions themselves are evidence. And let me read a little story to you that I wrote up, if I can find it. Alright, so imagine we're detectives and we're solving a murder case, okay? A wife found her husband dead in the garage. At the scene of the crime, we found a golf club and some golfing gloves with blood on them, obviously used to murder the husband. After investigating the scene and in interviewing the wife and the neighbors, reviewing the security footage, we decided to exchange our theories about the case. Alright, so you say that your theory is that a golfer broke into the house and killed the man with a golf club. He then left the club and gloves at the scene of the crime. And I say, yeah, but there was no sign of forced entry. And you respond, well, maybe he had a key. and he used the key to gain entry to the house. And I said, yeah, but that doesn't make sense because the wife said her husband didn't know any golfers and didn't golf. And so you respond with, okay, well, maybe it was just a stranger. He doesn't have to know him. And I was like, but wait a minute. The security footage also showed no one coming or going from the front door that day. And then your response is that a complete stranger, who is also a golfer, brought his golf club and wearing his golfing gloves to the house a day early with a key, went into the house, hid inside the garage for 28 hours, then used the golf club to murder the victim, leaving the club and their gloves at the scene of the crime. They then exited the house through the back door, climbed over the 8-foot-high privacy fence into the neighbor's backyard, and escaped without being seen. And so I'm like, okay, rookie, that is the worst story ever. What is your evidence for all of this nonsense? And you respond, well, A, the golf club was left at the scene of the crime, so it's obviously a golfer. B, the man doesn't know any golfers, so it was obviously a stranger. C, the golf gloves were found with blood there at the scene of the crime, so obviously more evidence that it was a golfer. There's no signs of forced entry, so obviously he must have had a key. And there's no security footage that shows no one entering or exiting the house the day of the crime. So that means he must have went early and stayed in there. And so my response is, assumptions are not evidence. Okay? Expansion is not evidence of expansion. The redshift is not evidence of expansion. Dark matter. Flat rotational curves is not evidence of dark matter. People say this all the time. I'm like, that is not evidence. Dark matter is the assumption used to explain the anomaly. Anyways, that one irks me because that happens all the time. And that's kind of like the scientific approach. Like that's what these people like Sean Carroll, when they defend their ideas, this is what they say. I literally heard that Sabine woman, like I have a clip of her saying that general relativity predicts the universe is expanding. It's like, no, it does not. And she said that's the evidence. It's like, no, it does not. What does that mean? What? It's the most inaccurate thing ever. Anyways, sorry, I'm getting excited. Let's move on to the next slide, Jamie. Okay, so in physics, evidence comes in many, many forms, okay? There's lots of different types of evidence that you can claim as evidence. But it really can only be considered evidence if the thing that it's evidencing, the idea that it's in evidence, in support of, already has like predictive power, mathematical continuity, a coherent like it has to be something, okay? You have to have something, a coherent message, and then you collect the evidence. You don't collect the evidence for all the little individual pieces. And that's kind of what cosmology has done. Examples, classical mechanics, obvious. I mean, there's all kinds of an amazing body of evidence in support of classical mechanics. Like, it is still valid. It still works well for most scales. You know, like you can't, like, relativity also has a ton of evidence in support of it. And so that's why it takes precedence over classical mechanics. But both of those have a large body of evidence. Same with the photoelectric effect, the standard model, and quantum mechanics. These things, you can have evidence in support of them. And you could have evidence in support of, say, dark energy. But type 1a supernova is not evidence of dark energy. Okay, that's when the anomaly was found. Number 1, general relativity. Okay, so when Einstein was doing all this stuff, his intuitions that the universe would be static. When Friedman showed him the calculations, it's reported that Einstein responded with, "Your calculations are correct, but your physics is abominable." Because it doesn't make sense. Why would the universe be expanding? Like, you have to have a causal reason for that. But it was a way to move the subject on, so Einstein was interested in that. This is the same paper I showed you earlier. But it's an interesting paper because Einstein's trying to figure out how to do this. Like, it's difficult because you have spatial infinity. And it's like, how do we get rid of that? Like, if I use the same density, if I try to draw a boundary around, say, a region that has that density, and then it's infinite space all around it, it's not stable. And so there's ways of dealing with it that he attempts in here, and there was nothing super satisfying for them at this time, but that's why the community was kind of excited about Friedman, Lemaitre. I don't know how to say that guy's name. The Jesuit priest, Lemaitre. I say it's Lemaitre, and that's how you say tomato in French. I know that much. It's Lemaitre, so I guess that guy's name is Mater. Anyways, and Robertson Walker, those guys were all working on this, so it took off because this is a difficult problem. They couldn't figure out how do we formulate the distribution of mass to make the universe stable. And so if it was expanding, that was kind of a way to move the conversation along. At least the universe would be stable if it is expanding. It would be stable now. And then we don't have to worry about the past. We can just ignore it like it didn't happen. And that's basically what they did. And that's where we're at today. Your calculations are correct, but your physics is abominable. You can't just say that the universe is expanding because it's convenient. Okay? But I have found a metric solution. Let me see where we're at. Okay, so this is later in 1931. He mentions that this is a different take, but it's kind of basically the same thing. The solution is not stable when you use this just a homogeneous mass density. You have to have something else. It's either going to be collapsing or expanding if you just have just a homogeneous mass density with infinite space. And so that's kind of where he was like, well, I can't figure it out, guys, so that's where we're at. But I've figured it out. And I'm not Einstein. I'm nowhere near. I'm actually a big dummy, okay? I'm a big dummy. I have a good intuition, though. I'll say that. My intuition is pretty good. And, I agree with Einstein. The physics is abominable. It's abominable. Expansion is stupid. So, to find the answer to this, all you have to do is work backwards from Hubble's law. Okay? We're not going to assume the universe is expanding. We're instead going to assume it's caused by gravitational redshift. Then, we figure out the density distribution that requires, or that the required density distribution to produce Hubble's law. And that's our density distribution. We use that to move on to step 2 to formulate a metric solution. I wrote Solutino. I guess that's for all the Mexican friends out there, my Latino friends. A metric Solutino. Anyways, you use this density distribution that you obtained from Hubble's law to form a metric solution. Okay, and you may think, oh, that's hard. Well, no, because the metric solution that it forms is the Schwarzschild metric. I mean, it's just the most remarkable thing ever. It's the simplest metric there is. It's a subset of the Schwarzschild metric. the density distribution is inversely proportional to the volume of space. So you don't have to have this infinite space. You don't have to have the universe just floating in infinite space. It's just whenever you're talking about whatever radius you're talking about, you adjust the density for that scale. And then when you do this is actually more accurate than a homogeneous distribution, because you can have a high density for the lower scales and a low density for the higher scales. And guess what? We already have a gravitational redshift. Like, we don't have to explain Hubble's law once we do this, because that's where we started. So, we don't have to explain inflation. We don't have to explain dark energy. I mean, I guess would be some interest in why there's a redshift anomaly, but it's obviously just an anisotropic or like an asymmetry in the observation. There's just more mass than there is expected, or something like that. Like, dark energy would be much easier to explain than it would be if the universe is expanding. And with dark matter, you also have this uniform gravitational acceleration that comes along with this metric. Now, I'm not going to get into that in this video, but that's a potential for dark matter. This opens a lot of doors, and this metric solution has not been published as far as I know. Like, this has never been talked about. And this is obviously true. Mass density is inversely proportional to the radius. And so that's my story. I'm sticking to it. If you've got a comment, that's great. I encourage you to leave it. Tell me how much you hate me. Tell me how stupid I am. Go for it. All these people with their crazy comments. I turn notifications off. I am no longer reading comments. I will occasionally go to the videos for maintenance. You just inevitably have to go back to the videos, and when you do, you read the comments. Like, it's just a habit on YouTube. As soon as you go to a video, you read the comments. And my comments have been awful, abysmal. Like, I hate you guys. Some of you are cool, but man, it's like people just comment even though they have no idea what they're talking about. Like, they didn't even listen to your video. They're 1 minute into the video and they're already making a comment. It's hilarious. Anyways, we're 30 minutes in. I don't know why you listen to this trash, but the joke's on you, because I just wasted 30 minutes of your time. However, it's not a true waste, because this is probably right. I'm probably right. I mean, like, it just makes total sense to me, and it would be hilarious if I am. Good night.